This is AQA A-Level Chemistry and it's the Year 12 topics Redox. This is part 4 of this topic. We've previously looked at rules to determine oxidation states, rules for building half equations. In this one we're going to review the building of half equations, but we're also going to look at the new rules for combining them. So as always, I'm going to recommend you pause, try the activities and then review when you follow through the rest of the video. So, as I've said, there are rules that you need to learn, and that's the third set of rules within what is a very short topic. So, when you are combining two half equations, you've got to make sure that one shows oxidation and one shows reduction, and then you are going to have to multiply up the entirety of that equation, or those equations, until you've got the same number of electrons on both sides. And that's because a full equation will never include electrons. So once you've done that, you simply combine everything from the left on both equations on the left, everything from the right of both equations on the right, get rid of any spectators that might exist, and you're left with the full equation. So we've got a worked example here. We've got the two half equations, iron being oxidised to iron 2 and manganate 7 ions being reduced to Mn plus 2. One of them does show oxidation. The iron is losing electrons. One of them shows reduction. The MnO4- is gaining electrons. But for rule 2, you can see that we have got 2 electrons and 5 electrons. Now I need to have the same number on both, so I need the lowest common multiple. So I'm going to multiply the top one by 5 and the bottom one by 2. That will mean I've got 10 electrons. Once I've multiplied them up, I simply combine them. So my 5Fe and my 5Fe2 plus from the multiple of the top one, and my 2MnO4-, my 16H plus, my 2Mn plus 2, and my 8H2O from the doubling of the manganate 7 half equation. At that point, you can see that there are certainly spectator electrons. There's nothing else that you do need to remove. So we're left with the equation that you see at the bottom. So we are going to look at some examples where you're going to build half equations and then combine them. It's also important that you note these definitions at the bottom. We've spoken about oxidation is loss of electrons, reduction is gain of electrons. So we need to think also about oxidizing agents and reducing agents. Now, an oxidizing agent allows something else to be oxidized, so that makes it an electron acceptor. A reducing agent allows something else to be reduced, which means it is itself oxidized. And if it's oxidized, that means it can donate electrons. So try the first example. Build the half equations, combine them, and tell us what's been oxidised and what's been reduced. Well, first half equation done here. Fe goes to Fe2 plus 2E minus. We do the same with the copper 2 going to copper. I'm double checking. I've got electrons on the right and on the left across the two equations. There are 2 electrons in each equation, so I don't need to multiply any up. And then I simply combine them, and I've taken the electrons out directly, and I get my Fe plus Cu plus 2 goes to Cu plus Fe plus 2. So what's happening in terms of oxidation, reduction, oxidizing agent, reducing agent? Well, the iron has been oxidized to iron 2. That means it's losing electrons, or alternatively, it's donating electrons and acting as a reducing agent. It's exactly the same thing, it's just looking at it from a different context. And if I look at the copper 2, that has been reduced from Cu plus 2 to Cu, and because it's reduced, that means it's gaining electrons. As an oxidizing agent, we say it's accepting electrons. Okay, next example. So let's combine these up. I need to follow the rules to build the half equations. I need to multiply my CRs. I've got 2Cr plus 3. I'm balancing the species with the variable oxidation state. I'm now balancing the oxygens by adding water. I'm balancing the hydrogens by adding H+, and I'm balancing the charge by adding electrons. I do the same with the Fe plus 2 to Fe plus 3. I don't need to balance the variable, or the oxygen, or the hydrogen. I just need to balance the charge by adding an electron. I'm then comparing how many electrons there are in each one. I've got 6 electrons in the top and 1 electron on the right, on the bottom, so I'm going to multiply the one on the bottom by 6 in its entirety. Once I've done that, I can combine my half equations. You can see my Fe2 plus, I've multiplied up to 6 Fe2 plus. My Fe3 plus, I've multiplied up to 6 Fe3 plus. I've kept the ones from the top equation exactly as they were. My electrons have gone. I've got rid of them. I've cancelled them out. And my dichromate 6 has been reduced to chromium 3. So it's acting as an oxidising agent. And my iron 2 has been oxidised to iron 3. So it's acting as a reducing agent. Next example. And once again, we build the half equation. My Mn is already balanced, so I'm going to balance my oxygens by adding water. I'm going to balance my hydrogens by adding H+, and I'm going to balance my charge by adding electrons. My Fe2 plus to Fe3 plus, I don't need to balance the variable species, or the oxygen, or the hydrogen. I just balance the charge by adding an electron. Now on this one, I've got 5 electrons on the top and 1 electron on the bottom, so I need to multiply my iron half equation by 5. I then combine them all together. So you can see again, my Fe2 plus has been multiplied to 5 Fe2 plus, my Fe3 plus to 5 Fe3 plus. I've got rid of my spectators, which are my electrons, and I can see that my manganate 7 has been reduced to Mn plus 2, and therefore is acting as an oxidising agent. And my Fe2 plus has been oxidised to Fe plus 3, so it's acting as a reducing agent. And remember, we can see this from the half equations as well. We know the MnO4 minus has been reduced because it's gained electrons. The electrons are on the left-hand side. On this one, Fe2 plus to Fe3 plus, we know that's oxidation because it's losing electrons, because the electrons are on the right-hand side. Next example. And I build my half equation, so I don't need to balance my variable, or my oxygen, or my hydrogen. I just need to balance my charge, 2E minus. My next one, HNO3 to NO2, well, my N is already balanced, so I'm going to balance my oxygens by adding an H2O. I then balance my hydrogens, adding an H+, and I balance my charge by adding an electron. When I look at my electrons here, I've got 2 electrons in the top half equation, 1 in the bottom, so the bottom half equation needs to be multiplied by 2. I then combine those into the full equation, spectator electrons have gone, and we're left with what you see here. I can then see that my copper has been oxidised to copper 2, so it's acting as a reducing agent. We can also see its oxidation because it's lost electrons in its half equation. And HNO3 has been reduced to NO2. It's acting as an oxidising agent, and again we can see here that it's gained an electron in its half equation, so from there we know that it's reduction as well. Going to finish off this video by introducing the concept of disproportionation. Easiest way to look at disproportionation is through examples. So can you identify what has been oxidised and what has been reduced in these equations? Well, what you've hopefully noticed is that the oxygen has gone from -1 to -2 in the water, but to 0 in the O2. So the oxygen has been oxidised and reduced in the same equation. One species oxidised and reduced in the same reaction. And that is what disproportionation is. So let's have a look at the next example, where we have got chlorine, oxidation state 0, has been reduced to HCl, but has been oxidised to HOCl. So in this case, we can say the chlorine has been both oxidised and reduced. That brings us to the end of this section. It also brings us to the end of this topic. Thank you for listening. Goodbye.